Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this is series number 3, analysis of frame using moment distribution method. So we are going to continue. Okay, in the first series, I have actually explained about this frame. So this frame is actually Sidesway frame. Sidesway frame because the frame is unsymmetry due to loading. Even though the geometry is symmetry, but due to loading, the frame will tend to sidesway to the right direction. So in order to analyze fixed and member and moment for this frame, we have to apply the principle of superposition. So we use principle of superposition because we want to uh, we want to divide the between the external loading and the delta which is come from Sidesway. So we have to have two parts of analysis, table 1 and table 2. So table 1, in table 1 we actually analyze in table 1 we actually analyze frame due to external loading only. So for doing this, we have to change the original frame to from unrestrained condition to fully restrained. So that in fully restrained frame, there is only FEM due to external loading. And in series number 2, I have discussed actually table number 1, discuss and calculate fixed end moment, and then calculate also end moment, member end moment, as well as I have also explained how we determine the restraining force in non-Sidesway analysis, table number 1. Okay, series number 1, I have actually explained the concept, how we derive the final formula to calculate member and moment, because we have to have the equation, the last equation, which we consider combination of external loading and Sidesway, because in analysis we cannot combine. In analysis, we cannot combine because external loading is the given value in the question, where we can calculate FEM, fixed end moment, directly, and we use that FEM value in table number 1 and as the first member and moment in the table, and then we continue the process, the distribution process, then we carry over the value, we repeat the distribution, we repeat again, carry over until distribution, the last distribution, then we stop until the last distribution, the moment under level distribution reaches 0 value, then we stop. So once we stop, okay, at level distribution, we have to plus all the moment in the table, start from the first moment value, which is the fixed end moment. So we plus start from FEM until the last distribution. So we get the member and moment for table number 1. But remember, in table number 1, we only consider external loading only. Okay, we have to have table number 2 because the delta which come from Sidesway, we do not know the value. So that's the difference between frame and beam, because in beam, the delta belong to support settlement, and support settlement is always given in the question. So when delta is given, then we can calculate FEM directly. So when we can have the FEM due to support settlement directly, so we can analyze the member and moment by combining FEM, or we can also have two table 1 for loading, table 2 for support settlement, and we can combine the member and moment at the end of analysis. However, in frame analysis, since one FEM is the value, the non-value, the real value. But another one, FEM due to Sidesway, due to delta, the delta is unknown. Is unknown until the end. It remains as unknown. So what we actually do when we move to part table number 2, okay, part 2 in analysis. So in analyzing FEM or analyzing frame due to delta, we only analyze based on FEM assumption. FEM assumption, and by using the formula, the FEM formula, we will find the FEM for another member because it will be based on the ratio. Then we use this FEM, put into the table, and then we repeat the same process, distribute, carry over, until the moment reaches 0, and we stop doing that. And we total. So the process in the table for both table A, table 1 and table B will be the same, except the FEM are different. The FEM one is come from external loading, which we can get it directly. And another one, FEM, table number 2, is based on assumption. So when we calculate FEM based on assumption, means that we have to correct the value. So in frame analysis, frame with Sidesway, we have what we call as correction factor. Correction factor. And correction factor we get from the restraining force. Restraining force. We have restraining force from table number 1. We have restraining force from table number 2. We label as R1 and R2. We label as R1 and R2 here. R1, no, R and R prime, sorry. R and R prime, not R1 and R2. Okay, R is come from table 1. R prime is come from table 2. Okay, so we get the correction factor. We get the correction factor, and this correction factor actually will correct back the value. So finally, by using interpolation, we get this. Okay, we get this. So this is actually the moment, member and moment due to delta. Okay, and I have explained how we derive this in the first series. Okay, so let's review first what we have done previously. Okay, let's review first what we have done previously. So, okay, this I have discussed in the first series, the derivation, how we get R divided by R prime times M, what is it? Okay, I have explained in the first series. In the second series, I move to step number 2, non-sway frame analysis for table number 1. So for each table, so we have to draw the free body diagram. Okay, the free body diagram. So this free body diagram, of course, I actually refers to the derivation. So you have to understand about this derivation first. Okay, so move to table number 2. Table number 2, in table number 2, okay, step number 3, table number 2. This is Sidesway frame analysis. Sidesway frame analysis. And from the derivation, table number 2 is this diagram. Table number 2. Okay, it is not the real frame. The real frame is C. Okay, the real frame is C, where the frame is subjected to restraining force. Okay, in right direction. So due to R, there will be delta, and due to delta, there will be end moment. And end moment for this frame is called as M. However, since delta is unknown, we cannot assume the delta. The delta is unknown, and we cannot assume the delta. So the one that we assume is not C. It's not C. So we introduce another diagram which is proportional to C. Introducing this, okay, this is the same, but this is another frame which is proportional to C. So if C, the frame is subjected to a restraining force R, okay, so we introduce frame, the same frame, but this is subjected to R prime. Okay, and due to R prime, the frame is Sidesway frame, and this R prime produce delta prime. Same as this, R produce delta. R produce delta, and with this delta, we can calculate FEM with this delta. But we cannot calculate FEM because the delta is unknown, and we cannot assume the real one. So delta is the real one. We cannot assume the real one, so we assume FEM for diagram D. So this D, we introduce it, okay, introduce it exactly the same with diagram C, but this is proportional, means that we actually derive M, okay, M, which is n moment for C, okay, based on the comparison interpolation. Okay, so this is the diagram that we are going to analyze in table number 2, okay, due to R prime. So we always analyze table 2 by using this type of frame. Means that in table number 2, the label is always R prime for the restraining force. The label is always delta prime for the delta, and the label is the end moment in this in table 2 is always M prime for the end moment. Okay, so this one we have to assume FEM. Remember, we don't determine delta prime, but we assume FEM, and we use this assumption in the table. So at the end of analysis, we find back the correction factor. Okay, so this is table number 2. This is table number 2, always. Okay, so looking back to the summary of the procedure. Okay, the summary of the procedure. So we are now calculating or analyzing Sidesway frame analysis. This is for table number 2. Okay, A3A FEM here we have to assume. We have to assume. Okay, based on assumption. Okay, so we should sketch first the diagram. So this will be the diagram. Okay, fixed at A and at D, but this time this is subjected to R prime, and due to R prime there will be delta. Okay, and this delta and this delta, okay, this delta and this delta, okay, equal. We assume it is equal. Delta at B, delta at C equal. Okay, equal. Delta. If for beam is horizontal member, delta is vertical. So now frame is vertical member, column from frame. Column is vertical member, so the delta is horizontal. So this is delta prime. And we assume that these two has same distance. So we can assume that both are delta prime. Okay, so we are going to analyze this. Okay, we are going to analyze this to calculate the FEM. Okay, wait for a while. Okay, now we will move to part. Okay, we move to part 2. Okay, part 2, this is for table 2. Part 2, this is for table 2. For table 2, this is Sidesway frame. Okay, this is Sidesway frame. Okay, here we have to draw the free body diagram. Means this is R prime. Okay, for table number 2, we always use R prime. So we have fixed. So we draw the free body diagram. So we have moment, okay, like this only. So we label A, B, C, and D. Okay, distance. The distance, this is 5 meter, 5 meter, 5 meter. EI constant. Okay, so this is AX, this is DX. Actually, all this must be put prime. Okay, so AX prime, DX prime, R prime, delta prime. Okay. Okay, what we should do is we have to understand about the Sidesway condition. The Sidesway condition. If for beam, the delta is vertical because the member is horizontal. This is for beam. This is for beam. But now we have vertical member which is come from column. So we analyze deflection in column. And deflection in column is going to be like this. Deflection in column is going to be like this. Okay, and we need to refer to the formula, fixed end moment formula. Okay, fixed end moment formula means that we have to apply moment at both. Okay, A and B. Let's say this is A, B. Okay, original is vertical. So AB is the member. So due to Sidesway, the column is tend to move to new position. New position means it moves this direction, in this direction. Okay, because R prime is located like this, going to the right direction, so the delta will be like this. This is the delta. Okay, so FEM, the formula, look at the formula first. The formula to calculate FEM due to delta is like this. So this is L. This is delta. And the behavior from original to new position, the angle, the chord rotation, okay, will be determined, okay, from original, means clockwise. Okay, so this is the angle. This is called as chord rotation. This is angle or chord rotation. This is formula given in appendix, where the moment, the fixed end moment for this beam, okay, for this beam due to delta, the moment will be like this. Okay, so it is different with beam subjected to external loading, because due to external loading, it is going to be like this, and moment will be like this. Okay, however, in support settlement or Sidesway, due to delta, okay, because fixed end moment is behavior, so we have to look at the behavior after Sidesway or after settlement occur. So we have to push back the beam to its original position. Okay, and we can conclude that for delta, due to delta, for the FEM due to delta, so delta can be support settlement, can be Sidesway. Okay, due to delta, what we can conclude is between chord rotation, between angle or chord rotation. Okay, when angle is positive, FEM will be negative. FEM will be negative. It is opposite. It is opposite. FEM, okay, angle is positive, FEM is negative. Means that these two have opposite condition. These two have opposite condition. Like this. If we have a column like this after Sidesway, so we have to apply moment to push back this point and this point to straight position. So how are we going to do this? So in order to make the incline to straight position again, we have to apply moment. In this direction and in this direction. Then only it can move back to straight position. Okay? Straight like this. Angle is going to be like this. And we have to push back. So it is opposite. Angle, okay, original is straight position. Sidesway, move to the side, whether it is left side or right side, doesn't matter, depending on the loading given, okay, or geometry given. Okay, it is the original position. So after Sidesway, it will move to new position. It is going to be like this, the column. Okay, so the angle will be measured from original, like this, move to new position. And this behavior, okay, this one, the angle is like this. The fixed end moment is like this. Means that the angle is like this. It is straight position. Angle is like this. Move to new position. This is the angle. Okay, moment, fixed end moment, push back. So between angle and FEM, it must be opposite condition. So whenever we analyze table number 2, part 2, so we have to consider this behavior. We cannot simply put the sign, but the sign representing behavior. So please put the right sign based on the behavior. Okay, so let's look at back to this. So due to R prime, the frame is tend to sway to right direction. The frame is tend to sway to right direction. So mark the angle. So the angle is here. Okay, mark the angle. So original. So this is, one is for AB, one is for CD. It is the same angle. Okay, one is for AB, one is for CD. So this is D, this is C. So this is 90 degree, perpendicular between length and the delta. Okay, so the angle we measure from original. Original is vertical, so this is the angle. Same. Okay, same angle. So when angle is positive, so I mark the angle positive. Okay, here angle is positive. FEM is negative. Because the angle is positive, FEM is negative. So we choose one to assume the value. Okay, we choose one to assume the value. So we assume FEM for AB and BA, both. One member ABBA, FEM AB, which is equal to FEM BA. Okay, so this one we have to assume the value. And in the textbook, the Hibbeler suggested we use 100. The value is 100, just nice value. Okay, just nice value 100, so we use 100. But it is not 100, but it is negative 100 because of the behavior. It is negative 100. So this one is negative 100. Negative 100, okay, kilonewton meter. Negative 100 kilonewton meter. We assume the value. Okay, negative 100. This is for AB. This is for AB, for delta. So FEM AB equal to FEM BA. Okay, we assume 100, but please don't forget to put the sign representing the right behavior. The angle is positive because the frame is tend to sway to right direction. Okay, so moment must push back. Okay, so that reaction is in opposite condition towards the angle. Okay, so we have to put negative here. We have to put negative. Okay, representing the behavior. Okay, now we have to apply the formula. We have to apply the formula. The formula to calculate FEM due to delta, okay, for both end fixed. So just assume both end fixed. Okay, even though we have two condition, end fixed and end roller and pin, so just you can just focus on one formula only. Okay, so we focus on one formula, end fixed. Okay, end fixed, the formula is 6EI delta prime over L squared. So the formula is 6EI. It is delta, but because of this delta prime, so we put delta prime. So delta prime over L squared. This is 5 squared. Okay, and this is equal to negative 100 kilonewton meter. And I want to put this, okay, the angle sign, which is positive, I want to put here to represent the opposite condition. So angle is positive, FEM is negative. Angle, I put in the bracket the positive angle. So angle is positive, 6EI delta over L squared is the formula. So EI, okay, and then delta. Delta prime, we use delta prime because this is for table number 2. We always label with prime, delta prime. Okay, so what we need to do next is we have to simplify this. So we have EI delta prime equal to negative 100 times 5 square divided by 6. Okay, divide by 6. So you can remain as this. Okay, use this whenever we calculate FEM for CD. Okay, FEM for CD. For frame with straight column like this, okay, frame with straight column like this, we only have FEM for A, B, and CD. We don't need to calculate FEM for BC because delta for beam is 0. Okay, from this position to this position, it move horizontally, so there is no vertical displacement, vertical deflection. Okay, we only focus on the horizontal displacement. Okay, so we continue to calculate FEM for CD. So we continue to calculate FEM for CD, which is equal to FEM for DC. Okay, so we apply formula. Okay, remember, so CD has the same behavior. The angle is also positive. And in this case, L is also equal, EI is also equal. Okay, so we apply the formula. So the angle is positive, put positive. Okay, it is 6EI. Okay, it is delta prime over 5 square. And in this case, EI is constant, L is constant. L is constant, L is constant, EI is constant, delta also constant. So what we get is actually when we substitute EI delta prime, which is equal to negative 100 times 5 square divided by 6. Okay, so we will get like this. Okay, this is 6 EI, no, 6 over 6. It is 6 over 5 square. Okay, times with negative 100 times 5 square divided by 6. Because of the symmetrical condition of beam AB and frame AB and column AB and column DC, so because the ratio is 1, this is 5 meter, this is also 5, the same ratio. Okay, 6 and 6. Okay, EI constant, L also constant, so what we get is also the same, negative 100 kilonewton. Negative 100 kilonewton means that we have 4 fixed end moment value due to Sidesway, and the 4 value are equal, negative 100, because it will be influenced by whatever given in the formula. The formula is 6 EI delta over L squared. So means that it will depend, the ratio will be depend on EI, the ratio will be depend on L, the ratio will be depend on delta. Now this is the case where EI is constant, L also same. That is why the ratio is 1. When the ratio is 1, we will get the same answer, negative 100. Negative 100. So next example, we will do different frame with different not constant value, different L, different EI. Okay, so we get this is kilonewton meter. So we have now 4 values. Okay, 4 values. Okay, I move to Excel. Okay, this is actually table number 1. So I copy this and paste. Okay, the difference between two tables is only at FEM value. Okay, FEM value. The first table, FEM, is based on the external loading, and for the second table, it is based on the Sidesway. So okay, so we will change the FEM. We change the FEM for table number 2 to negative 100. Okay, for BC it is 0. For CB is also 0. Okay, and then negative 100, and then negative 100. So we just need to change the FEM. Okay, so we have to calculate the new value. So we repeat the process again. Okay, the first distribution is for joint A. However, joint A, the factor is 0, so we get 0. Okay, we move to join B. Join B, we have BA and BC. BA and BC. So always remember that join moment is opposite with member and moment. So we have to put negative to represent the opposite condition. So it is negative 100 plus 0. We have to times with the factor. The factor is 0.5. Okay, so we get positive 50. Positive 50. Okay, again for BC, join moment at B. Join moment at B is 100. Okay, we times with the factor. The factor is 0.5, distribution factor. Okay, so we get 50 and 50. So total, we get back 0. Okay, we move to join C. We move to join C, so we get okay, negative 100, positive, times with the factor. Factor is 0.5, so we get 50. So we get the same here. Okay. Negative 100 times 0.5. Okay. Okay, now we have to carry the value. We have to carry the value to opposite join. Means that B, we have to cross to A. B, we have to cross to C. B, A to A and to C. Okay, C to B and to D. Okay, so BA, we have to carry the value. So just look at the highlight color. So that's the process of carry over the value. So the factor is 0.5 for fixed end and internal support. Okay, rigid joint is also internal support. Okay, internal joint. Okay, so this is 50 divided by 2. 50 divided by 2. It is 25. Okay, the orange BC, we have to carry to CB. We have to carry to CB. So this is 50 divided by 2. Okay, the green is CB. We carry to BC. We carry to BC. It is 50 divided by 2. Okay, and the blue. Okay, the blue is also same. So we have to carry the value. We have to carry the value. It is 50 divided by 2. 50 divided by 2. So we get 25. So we repeat the process again. Okay, we repeat the process again. Times with factor. Okay, this is actually the example in the textbook. The first example of frame analysis in the textbook. This is quite straightforward. That is why you find the value like this. But in real one, you will find it is quite uh, not complicated, but it's quite difficult because all the value is not like this. The value we have different type of support. We have different EI. We may have different length. Okay, we may have different delta as well. So all value is not going to be easy like this. Okay, so but the most important thing is you understand the process. Okay, so next is BC. So negative 25 times with the factor. Okay, so again negative times with the factor. Okay, we put negative 25 times with the factor. It is 25 plus 0. It is 25 plus 0. Okay, and then we need to carry the value again. Carry the value again. So it is 12.5 divided by 2. And then we carry the value BC to CB. So it is 12.5 divided by 2. Okay, we have to cross cross boundary divide by 2, and then this one also cross boundary divide by 2. Okay, so continue, repeat the process. Repeat the process again for the next distribution. So in the table, we just need to repeat the process. One cycle means have one distribution, one carry over. That is one cycle. Okay, we have to repeat the process until the last distribution. Start with distribution, end with distribution. Okay, so distribution. So we put negative. So it is 6.25 times the factor 0.5 is 6.25 times with 0.5, because the EI and the length is equal, so that is why the factor also 0.5 equal. Okay, 6.25 times with 0.5. Okay, and doing the same process again and again. 6.25 times 0.5. Okay, carry over. We carry the value again. Divide by 2. Okay, we carry the value again. Okay, because the factor is 0.5, and carry the value again. If it is n pin, we cannot carry the value because the factor is 0. So careful, yeah? Careful. This is fixed. A is fixed, D is fixed. That is why we look, it look like easy like this. But whenever the NA or ND or one of these is not fixed, it is one fixed, one pin maybe. Okay, so remember, for n pin and roller, the factor is 0. So you have to be careful. Okay, you have to be careful. Okay, carry over distribution. Carry over distribution. Okay, distribution again. Normally 5 times or 6 times, then you can get the 0, near to 0. So 1.5625 times with factor 0.5. Okay, don't forget to put negative. Okay, because the value must be in opposite. Okay, times with 0.5. Joint moment, we distribute joint moment, and joint moment is opposite with member and moment. Opposite with member and moment. Okay, wait. Wrong place. Negative 1.65 times 0.5. Okay, times 0.5. So how many distribution? Distribution number 1, number 2, number 3, number 4. Now, distribution number 4. Okay, we will continue to the last distribution. Carry over first. Okay, this is carry over. Okay, carry over. We just use up to 3 decimal places in the table. Okay, just use to 3 decimal places. Okay, I will format it later. Divide by 2. Divide by 2. And divide by 2. Divide by 2. Okay, and the last distribution. The last distribution, 0.39 times with 0.5. Okay, times with 0.5. 0.39. 0.39. Okay, 0.39 times with 0.5. Okay, 0.5. 0.39 times with 0.5. 0.5. And last distribution, 0.39 times with 0.5. The distribution factor. Distribution factor. Okay, so now I want to change this to 3 decimal places. 3 decimal places. Okay, 3 decimal places. Okay, 3 decimal places. Okay, the answer okay. Okay, the answer is like this. 3 decimal places. And this one. Okay, so we get this one is table number 2. Table number 2 is not M naught, it is M prime. M prime. Okay, so this is the answer for n moment due to side sway. And for the side sway frame, we base on assumption. We have to assume FEM for one column and find another FEM using ratio and interpolation. Okay, so copy and put back to this. Okay, so this is the value. Okay, so once we have got the value, okay, now we are in step 3. In step 3, so we have done this. Okay, FEM due to Sidesway based on assumption, and then due to the FEM that we get based on assumption, we put into the table number 2. We determine M prime, and after that we will continue to calculate restraining force. The same process, this process and this process are the same. Okay, except the value are different. We have to write shear equation, and we have to do column analysis in order to determine, okay, the R prime value. Okay. Okay, so what we should do is like this. So we have the frame. So this is AX prime, A dx prime. We have R prime like this. Okay, we have AX prime, AY prime. This is dy prime, and we have moment as well. Moment is negative here, and negative, negative. Okay, so from this we will write the shear equation. Okay, for the shear equation means we write total fx is equal to 0. Total fx is equal to 0. So what we get is ax prime minus dx prime plus r, it is plus. ax prime minus dx prime plus r equal to 0. So we get r is equal to dx prime minus ax prime. Okay, this is the formula. This is not r, this is r prime. Okay, this is the formula to get r prime value. Okay, the same process like previous. Okay, this one for the first table, r is ax minus dx. Okay, r is ax minus dx. Okay, but the second one, it is r prime equal to dx prime plus ax prime. Okay, so we do column analysis. It is called as column analysis, means that we have to extract the column. Okay, the information about the column. The moment is negative. So the moment is 80.078 and 59.961. 59.961. It is 5 meter, and we have ax prime. So doing column analysis. Column analysis means we take moment at B. Because this is A, this is B. What we want is AX. So we have to take moment at B. Take moment at B, so what we get is negative 59.961 minus 80.078 minus as well minus 5 AX prime is equal to 0. Okay, so we get AX prime equal to negative AX prime equal to negative 59.961 minus 80.078 divided by 5. Okay, so it is 59.961, 80.078 divided by 5. So it is 28. It is negative 28.008 kilonewton. Then we will do the same for column CD. So this is D, this is C. The moment, okay, exactly the same actually. It is also negative. Okay, this is also negative. And negative. So this is dx. So it is 80.078 and 69.961. Okay, 5 meter. So since we want to calculate the x prime value, so we have to take moment at C, which is equal to 0. So what we get is negative 69.961, okay, minus 80.078. Now we have positive plus dx. plus dx prime. It is 5 dx prime is equal to 0. So we get dx is equal to, previously is negative, now is positive, 28.008 kilonewton. Okay, so this is dx prime, this is dx prime and ax prime. Dx prime and ax prime. This is dx prime, this is ax prime. So we substitute into the shear equation, into this, the shear equation. Okay, so we get r prime equal to dx. Dx is positive. Dx is positive 28.008 minus negative 28.008. So this is equal to, you get 56.016 kilonewton. Okay, kilonewton. So this is r prime. This is r prime. So we have until this stage we actually have come to the last step, because under table number 1, we calculate m naught and r value. Okay, and r value, and under table number 2 we calculate n moment m prime and r prime value. So once we get all this, so we move to the last step. Okay, step number 4, which is the last step. So in this step we want to calculate final end moment, and this is equal to m naught plus correction factor r divided by r prime times with m prime. So what is m naught? This is from table number 1. What is m prime? This is from table number 2. Okay, r we calculate based on m naught value, r prime we calculate based on m prime value. So we have the correction factor. So we just need to substitute all the value, and we get the final end moment. The final end moment. Okay, so that is the process. That is the process. Okay, that is the process, and this one is actually, as I mentioned, this is the question in the textbook. Okay, let's see together the textbook. The textbook under chapter number 12. Chapter number 12. Okay. This one. Okay, this is actually chapter example 12.6 in the textbook. Okay, in the textbook, this is the question. We discussed since SIRI number 1 until now. Okay, this is the same. We have table number 1. We have table number 2. Okay, table number 2. And then finally, we use the formula. And we calculate the final end moment. Okay, so actually I just showing you this for you to understand about the process of moment distribution method for frame, because next after this we will focus more on the frame with Sidesway whenever EI is not constant, L is not constant. Okay, because when the length is not constant, when EI is not constant, of course you have to be careful. Okay, whenever you find the K value and df, as well as whenever you want to assume the FEM, assume the assumption. Okay, the assumption, because you will get something like this. Okay, assumption is 100, but the ratio that we get for another column is not 100 anymore, because the ratio is not 1 to 1. Okay, so this will be the next the next discussion that we are going to have. Okay, after this, in the next session. Okay, so I think so 1 hour, sharp 1 hour. So I have to stop now. So I want you to continue, to just look back at the video. Actually, there are many video discuss about this. Okay, and I have also I also I also have video where I simplify the procedure in determining the FEM due to Sidesway, based on the assumption. So I use ratio in order to determine the value. So I have video on that also. So please watch the recording. Okay, inshallah, the next video we will do another frame example, something like this. Okay, something like this where the length is not constant, EI also not constant. Okay, so thank you very much for those who watch this series. I hope this will help you to understand. Okay, please continue to do exercises. Okay, we have to do a lot. Okay, one is not enough. Okay, so because test 2 will be based on topic number 3, one beam question, beam with support settlement, one frame question, frame with Sidesway. Both will be given in your test. Okay, so please get prepared for your test next week, inshallah. So hope this will help you. If you have any question, please let me know so that I can highlight in the next discussion. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.